overall uranium fuel cycle and explain the nuclear process in detail. Or extraction, conversion, transportation. Extraction, conversion. Uranium ore is mined. Uranium ore is milled into yellow cake. Yellow cake is turned into UO2 and then gas UF6. This is UF6 is energized enriched to increase the amount of U235. This UF6 is again enriched to increase the amount of U235. Enriched UF6 is converted back to UO2 and made into ceramic fuel pellets. Pellets are put into fuel rods and used to make electricity. Used fuel is stored at the power plant site. The used fuel may be reprocessed or stored in an underground repository. Step is extraction. Extraction. Here mine ore extracted in underground mines or surface mines. Usually we know that mine ore will be extracted underground mines or it is a surface mines. Tons of uranium ore in the US contains 3 to 10 pounds of uranium. Milling. So second step is milling. Uranium ore is crushed. Okay, first we extract uranium ore and then in the milling process uranium ore is crushed and crushed ore plus acid which dissolves the uranium but not the rest of the crushed. The acid solution is drained off and dried. Acid solution is drained off and dried, leaving a yellow powder referred to as that is yellow cake, consisting mostly of uranium. So this process is done to remove the other content and only it will be uranium is left. This process of removing uranium from the ore is called uranium milling. So here we get a pure uranium from the uranium ore. Ore is removed from this process, milling process. Next is a conversion. Yellow cake is converted to gas called UF6 or uranium hexafluoride. Here conversion is yellow cake is converted to gas called UF6 or uranium hexafluoride. Next is, so we have converted to yellow cake and that is a enriched. Next step is enrichment. The process of increasing the percentage of uranium 235 from 1 to 5%. Okay. For example, if it is in this process it is 1%, then in the enrichment process it is increased to 5%. Uranium 235 has 3 fewer neutrons and is 1% lighter than uranium 238. It moves through the holes more easily than U238. This method increases the concentration or percentage of uranium 235 as the gas passes through thousands of filters. So here this uranium 235 has 3 fewer neutrons and 1% lighter than uranium 238. It moves through the holes more easily than U238. 235 moves through the holes more easily than U238. This method increases the concentration or percentage of uranium 235 as the gas passes through thousands of filters. Next is, this is the enrichment process, and next is a fabrication. Uranium is made into a solid ceramic material and formed into a small barrel shaped pellets. You can observe this is so it is converted into a small barrel shaped pellets. Okay. Uranium is made into a solid ceramic material and formed into a small barrel shaped pellets. Ceramic fuel pellets can withstand very high temperature similar to the ceramic tiles what we use. Okay, ceramic fuel pellets that can withstand very high temperature which is similar to the ceramic tiles on the National Aeronautics and Space Administration space shuttle. Pellets are sealed in 12-foot metal tubes called fuel rods. Fuel rods are bundled into groups called fuel assemblies. The next is nuclear reaction unit. Here fission takes place in the reactor core. Fission takes place in the reactor core. Surrounding the core of the reactor is a shell called the reactor pressure vessel. So here fission takes place in the reactor core. Surrounding the core of the reactor, there is a shell called the reactor pressure vessel. Control rods absorbs neutrons and slow down the nuclear reaction. What the control rods will do? The control rods absorbs neutrons and it will slow down the nuclear reaction. Water flows through the fuel assemblies. Water flows through the fuel assemblies and control rods. Water flows through the fuel assembly and control rods. What it will do? It will remove some of the heat from the chain reaction. It will remove some of the heat from the chain reaction. The nuclear reaction generates heat energy in a manner similar to how burning coal or oil generates heat energy. This heat is used to boil water into steam that turns a turbine generator to produce electricity. This heat is used to boil water into steam that turns a turbine generator to produce electricity. Steam is condensed back into water and cooled. Again steam is condensed back into water and cooled. Okay. Next is a waste management. The fuel that is taken out of the reactor is called used fuel. The fuel which we use taken out of the reactor is called as a used fuel. The used fuel contains both radioactive waste products and unused fuel. Okay, it contains both radioactive waste product and unused fuel. The used fuel is usually stored near the reactor in a deep pool of water called used fuel pool. The used fuel then cools and loses most of its radioactivity through radioactive decay. The used fuel then cools and loses most of its radioactivity through radioactive decay. Used fuel pool serves as a temporary method for storing used nuclear fuel. There is no permanent storage solution yet for used nuclear fuel, and space for fuel pools may be running out. So next is a reprocessing. It separates the unused nuclear fuel from the waste products so that it can be reused in another reactor. It separates the unused nuclear fuel from the waste product so that it can be reused in another reactor. Reprocessing is more expensive than producing new fuel from uranium ore. Uranium prices rise significantly or storage become a bigger problem. Reprocessing may gain favor. Reactor itself is the key unit. Reactor types: pressurized light water reactor, light water boiling reactor, heavy water reactor, high temperature gas cooled reactor, liquid metal fast breeder reactor, light water breeder reactor, gas cooled fast reactor, molten salt reactor, molten salt breeder reactor. So you can observe here. So light water reactor, first one point you remember, pressurized light water reactor. In that again light water boiling reactor. Okay, heavy water reactor, again high temperature gas cooled reactor, STGR, heavy temperature gas cooled reactor, liquid metal fast breeder reactor, liquid metal fast breeder reactor. So light water, this is heavy water reactor, here light water breeder reactor. Okay, next gas cooled. So gas cooled reactor, gas cooled fast reactor. Next molten salt reactor, molten salt breeder reactor.